So the first part of the question is using Gauss-Jordan elimination to solve the equations that are given. So the two are x minus 5y equals 35 and 5x minus 4y equals 28. So first you want to write the system of equations in matrix form. So that's going to look like this. Now you want to row reduce. So first I did negative 5 times row 1. This is your row 1 at the top, and this is your row 2. So negative 5 times row 1 plus row 2 is going to give us a new row 2. Notice how when it goes from here to here, just like this part says, we're keeping the same row 1 but changing row 2. This is going to help us to convert our elements down to 0 and 1 so we can get a final solution. So here we changed to a row 2 by doing negative 5 times row 1 and then adding that to our row 2. So it looks like this. And you're going to have to keep doing these types of steps until we can get it to look down like the bottom one does. So then we have 1, negative 5, 35, 0, 21, and negative 147. Okay. So now we look at it and we say, what can we do next to get maybe 21 to look like a 1? So I chose to do 1 over 21 times row 2. And this will give us our 21 to turn into 1. So when you do that math, you're going to get 0, 1, and negative 7. Notice how our row 1 still did not change because we're only impacting row 2 right here, both times. Finally, when we have this, 1, negative 5, and 35, 0, 1, and negative 7, that we're finally going to change our row 1. So how are we going to get row 1 down to 1s and 0s? I chose to multiply 5 times row 2 so that our 5 and negative 5 cancel out because we're going to add it to row 1. So it would be 0, 5, and negative 35, which fits perfectly when added to our row 1 to give us a new row 1. So it will look like 5, it will be 0, 5, and negative 35, which gives us a 1, 0, and 0 on top. Do you see how if I did that right, it should give us 1, 0, 0, 0, 1, negative 7, and these are the numbers we will look at for x and y. So it will be x, y equals 0, negative 7. These are our x and y values. X equals 0 and y equals negative 7. For the second part of this equation, it asks you to use matrix inverses. So this can get a little tricky, but first you're going to write it as a matrix, just as we did last time with our x and y's. And now to set it up more easily for myself, I kept it in separate matrix forms. So x, y, and then you have your first part of the equation, this part, and then the 28 over 35. So you want to multiply both sides by the inverse. When you do that, you want to find inverse of the matrix. So this is going to happen by multiplying by what you need to make this into the inverse. So after doing the math, you find that it's 5 over 21, 1 over 21, negative 4 over 21, and negative 5 over 21. Then you are going to simplify this so that you come up with your x and y values. So x and y values here are 0 and negative 7, just as they were for our Gauss-Jordan. It's just a different way of doing it. So you should come up with the same result. So x equals 0 and y equals negative 7.